Welcome to the GEF training video. This is a GEF VH model, easily identified by the vent hood that's built onto it. That's the VH standing for ventless hood. It is a freestanding recirculating hood. Doesn't need an additional hood. It actually brings the air and recirculates it back into the kitchen. For the sake of this video, we're going to talk about just the fryer itself. We're going to leave this out of the equation. I've turned the blower and all off so we won't get any of those alarms. You will notice there's an extra set of lights over here for the EAC filter and an Anson pull for the fire system. Again, we're just going to do from here on over. I'm going to do the regular fryer. Did not have one available at the time of this training. So if we're looking at the front of the fryer, we have the power switch over here. We have our selector switch, which is our cook filter. Center position is off, so we're not cooking or filtering. And then this is the CC10 controller. The CC10 controller is easily identified by the red clear button, the green start button. It'll have a blue display up here and then red down at the bottom. We have our power, heat, high limit lights. During normal operation, the power light will be on. The heat light should accompany this heat light. Every time this heat light over here is on, if this is in the cook position, you'll see this orange light come on, signifying that we have power to the heat contactor. And then the high limit. If the machine gets over 450 degrees, the high limit module will react. It will turn this light on and drop out the safety contactor in the back. Now to start, you'll just hit the power button. You'll see it comes up, it goes through the diagnostics. It says power failure. Press start to preheat. So we're going to press the start. Immediately it says preheat 350 degrees. You'll see right here where it says press boil out to go to boil out. Under normal operations, we could press that boil to go to boil out. In this case, we want to go ahead and allow it to heat. We have our heat light right here. So our power light is on. Our heat light right here is not on. And the reason for that being, we have this in the center position, not in the cook. So if I flip it to cook, you immediately see that light come on and the unit starts to heat. I don't have any oil in here right now, so I don't want to let it heat. Now these videos take into account that you have a basic electrical and mechanical knowledge, and one of the most important things you can do is protect yourself. So for lockout, tagout safety, I've tracked this back to this number 3 circuit, this unit that we're working on. We're going to turn this to the off position, and then I'm going to attach this lockout device, which just has a screw here that locks into here. Okay, once snugged and in place, that cannot be moved. Okay, then I'm going to go ahead and I'm going to put a padlock on there that says it's locked out. I'm in control now with the power. When I'm done, I'll take it back off. But in the meantime, I'm going to leave this on while we discuss some of the electrical things that have to do with this fryer. And I have the key. So as long as I have the key, I have control. And we just want you to be safe. You should do the same thing. However you guys are set up, I don't know what kind of lockout tagout devices you have. This one works rather well on most breakers. One of the biggest issues in the field that we hear of are not filtering issues. Many times the pump will not recirculate the oil. It will be dropped down to the filter pan, but the customer can't get the pump to pick it back up, put it back up into the fryer or through the discharge coupling. Of course, one thing you want to do is make sure it says oil diverter valve. It's a 3-way valve. You want to make sure that it is set to the fry pot if you want it to go to the fryer. Or if you go to the discharge hose coupling, you'll have to have something right here. This coupling has a check valve built into it so that to prevent hot oil from just getting sprayed out at the customer if there's nothing there. So we're going to go ahead and put it to the fry pot right now. But one thing that we want to do, if we can't get it to pump at all, go ahead, you can turn the filter pump on and stick your hand over this coupling. This coupling right here, this is for the filter pan. This will go into here. And you should feel a suction right there when that pump runs. It's not a huge suction, but you will feel a little bit of a suction right there. Okay? Okay? This turns out this is a very good time to talk about the pump itself. If these set up for quite some time, oftentimes that pump will lock up and the pump will not want to run. So what we want to do is we want to go back, we'll take a look at the pump and see what we can figure out back there. Okay, so let's look at the filter pump. Here's the pump plumbing. This comes from the quick connect in the front. It comes through the pump, through there, comes around. This is your three-way diverter valve that we talked about in the front. This goes back up into the fry pot, and this other line goes to that hose coupling. So depending on which way you've got that valve, here's your handle right here. It comes in. It's either going to go to the back up into the fry pot, through the hose coupling. Very straightforward situation. Again, we were having pump problems, so let's go ahead. We're going to pull this inspection plate right here, and once we pull this inspection plate, then we'll see what's going on inside there. Now this is a brand new pump. It's just that the unit has been sitting up for a little while, so. It's probably a little cleaner than what you'll see in the field many times. Okay, once all the bolts are out, you'll have to tap this cover up a little bit. You see it come up? Once that cover comes up off of there, it may take a little extra prying here. Now you can see, here's the cover, and you can see where there's been a little bit of sludge and stuff that has gotten caught up in there from where it's been used. But if you'll take a good look right here, you can actually see there is a gear down inside there, right here, and this is a gear pump. So this pump will go ahead and, as it turns, it churns up all those particles. And for whatever reason, it was not running. Now I'm going to walk around the front real quick and turn the switch on, and we'll allow that to run just a second, make sure that it's turning. Now that we know that the pump is churning, we know that it should be able to go ahead and pump. So let's go ahead. You can pull this gear out and make sure that you've got it good and clean. This little piece right here is what goes down into the pump motor itself. This is the driver. So when you put it back in there, you'll have to make sure, turn it till it drops down into the motor, and it'll drop all the way down in nice and flush. Now once it does that, then we can go ahead and put our cover on. You'll see there's a gap on this side. This goes right there. Okay, push her down. We're going to put in the 4 bolts. You want to run them in finger tight. Once you get them in finger tight, then just a little snug, not, would you feel a little bit of pressure on there, then you want to stop. And make sure that you're going in a cross-hatch motion. Do not just tighten up these two over here on one side. You'll cock that sideways and then it won't work for you. Now that I've got those just snugged up, I'm going to turn the pump on while I finish tightening those up. Okay, now that the pump is running, finish tightening these up. we don't want to let the pump run dry for long, so we want to do this in a fairly quick motion. I'm going to go ahead, turn the unit back off. Okay, now we can go back around the front and let's see whether or not we've got this pumping. Okay, now that we've got the pump cleared out and it sounded like it was going to go, let's go ahead and we're going to turn the pump on. Let's see if we've got success. Coupled up. Ah, sounds like magic. All right. We'll take the basket out. And you can actually see the oil returning right here, coming back into the fry pot. Okay, we have the drain valve closed right now so that we can go ahead and let that fill back up. So that's how you get your pump to go. It's not always that easy, but in most cases, that's all it takes. Now these pumps have a thermal overload in them in the motor. So sometimes what will happen is the motor will actually kick off. It has to cool down, it'll come back on. It'll kick off, cool down, come back on. And you'll hear that from the customer. In most cases, it's because they have the discharge valve with nothing here, so you're deadheading your pump. Or this is so stopped up down in the filter pan that it can't pull any oil and it's working too hard. So it brings the amps up, it heats up the motor, and it'll shut itself down. It's a thermal overload. It goes off on temperature. Now, if we were going to remove this filter pump, all you'd have to do, you would break this union here. This pipe right here goes out to that quick connect for the filter pan. Take the quick connect off the other end of it, or you can just unscrew it from here. Take your pipe wrench, unscrew it from here, and slide it forward. But that'll allow this to come out then. And that's it. You've got two fittings right there. Your wire's right here. You've got this nice little shelf here to set it on once you get it out. So you can go ahead and lay it down. You've got your 4 bolts here that mount it. And that's it. The pump is ready to come out. To remove just the pump, you've got set screws right here. There's 3 set screws on this little snout on the motor. And you can separate those two once you get it out, just by undoing those set screws. So again, take it loose here. Make sure, again, oil is going this way. It's coming from the front, going to the diverter valve. So always make sure that your orientation is correct on your pump, and you can change that by undoing those set screws and flip the pump around. You can do it 180 degrees if you need to. Typically they come straight from the factory. They'll already be the way that you need them, so that's never an issue. Now we want to talk about the filter pan and the kind of issues that you'll have if it's not put together right. You'll notice that there's 4 of these little latches in the bottom of this pan. This screen in the bottom is welded in. It's welded so that they can't lift it out. And it keeps the paper from being sucked against the bottom because you're pulling from right here in the center. So it allows that oil to go down through, leaving the sediment on top of the paper. You 4 of these latches for preventive maintenance. You definitely want to go ahead and make sure all of these are intact, and make sure that when we put this in, you'll see here in just a second that they latch down good and snug. Otherwise, it'll allow that debris to get down around the paper. Now, to properly put this together, the first thing we're going to do is go ahead, we're going to put the paper in there. All right. Now, your filter paper, if it's properly sized, will fit right within that frame. It's not on top of the frame, but it's down inside of it. Okay, then after that, we have our hold-down frame. This hold-down frame also goes right in there. And that's what's going to press that paper down and get that nice sealing edge around here. So then we're going to go ahead and we're going to pull these over. I'm going to say they need to fit good and snug, or they're not going to do much good. You see how loose that one is? What we need to do is go ahead, pull this back out, and then let's try to bend that down just a little bit. Get a little bit of tension on it. So we'll just force them down a little bit. You won't get a lot of bend. They're pretty strong. Okay, and then we'll try this again. Sometimes you have to take and actually put a pipe wrench on them or something to bend them down. But that made it a little bit tighter. Tighter. Okay, so all of that is together now. Now the filter pan is right. So what they would do generally is go ahead, they would cast, but however they have filter powder, they would go ahead and spread that across. What the filter powder does is that it allows all the real fine particles of flour to combine to make them larger, so they won't stop up the pores in the paper. Think of this as making coffee. This is your coffee filter. If it's not in there right, you're going to get grounds in your cup. We don't want the grounds in the cup. We don't want the grounds coming back to the fryer. Okay, so once we get that together, we put the top on, holes to the front, and slide her up in there. Now this coupling right here, it goes up in there, make sure that that white collar pops back out. If not, then it's not seated correctly. Well, let's talk about your basket lift just a little bit. This is your lift arm right here, okay? And this is what we call the basket pin. This actually lifts right up off of there. This pin is just held on by 2 bolts in the back. And this is what actually grabs the basket and lifts it up, okay? Got a slot right here, goes down on that drift pin right there. It'll keep it nice and rigid. Now to check the elevator, what we're going to have to do is we're going to have to go ahead, we're still got the cook switch off, so we're going to go ahead and hit start. Now we want, this is set to 350 degrees. That basket will not go down if the temperature down here does not match that, okay? Just to prove it, we're going to hit basket, and see it says up only. It does not even give us a choice, only the up arrow is on, so we can't do anything there. So let's go ahead and clear that out. We'll set our temperature to 75 and start, okay? And you saw how I did that. I just pressed. All I did was temperature, and then I put, oops, it's gonna keep on alarming to tell me that it's up to temperature now. But again, you're gonna hit temperature, and we'll do, just for the sake of it, we'll do 80, and then start. Okay, now that's a manual temperature, and it says it's manual. Okay, so let's go back to where we were, temperature, 7.5, start. Wait for it, see if it's gonna alarm. I don't think it's going to. It says ready. Okay, now that it's up to temperature, we can hit the basket. And see, it gives us a choice of up or down. And it says number 8 is down, so we'll press number 8. You see the basket going down. Okay, now once that basket goes down, you have to wait for the basket light to turn off. Once that basket light turns off, then you can go ahead and reverse course if you want. You can hit basket and go back up, but it has to time out. It's got a 30-second timer. Okay, it just went out, so we can hit basket again. It gives us a choice, up or down. Well, it's already down, so let's go up. And we'll go ahead and go back up. Very simple process. Then when they start a menu, it'll automatically drop it. So let's go ahead. Okay, we're up to temp. Let's press start to cook. So it'll go ahead just as if we were starting a menu. And you'll see it drops down and it starts timing down. It had a 2-minute manual setting in there. Now at the end of that 2 minutes, well, before the 2 minutes is up, it'll go into a stir alarm at 3/4 of the cook cycle. It goes into a stir alarm, and that's so that they can stir the product to keep it from sticking together. And then go ahead, after, when it finishes, it'll go ahead and it'll raise that basket back up, okay? I'm just gonna go ahead and we're gonna press clear to stop. And again, it's gonna tell you to do it again. And the basket comes up. So that's how you operate the basket, just to check operation. Okay, let's talk about the basket operator. This is your entire basket lift. This whole assembly, it goes from here on down. This is that rod we saw on the other side that actually lifts the basket. It goes up through this cylinder. This cylinder is filled with oil to this point right here. You've got a little fill screw here. 20W50 Castro motor oil is all that's in there. It's held in place by these 2 U-bolts. It's got bronze bushings in there and then seals on each end. It's got a set collar down here on the bottom. This set collar has this finger. It's actually looking like a piece of key stock. and it slides between these two pieces of plastic over here, or UHMW. When it comes up to the top, it'll make this micro switch. The micro switch is wired normally closed, so it'll go ahead and break the circuit on these two yellow wires. Yellow is up. It'll kill it'll break this circuit, kill power to the motor. When it goes down, this same key goes down, it makes this micro switch down here that has two orange wires on it, breaking power to the motor going down. But the basket elevator has this gear motor on the bottom. The gear motor actually has a brake inside of it. If you were to push on the shaft at the end, you can actually feel it. When we energize the armature, it releases the brake, which allows the motor to go ahead and move. When you kill the power to the motor, that brake will go ahead, it closes back up and it seizes and keeps it from turning. Idler sprocket at the top. We've got 4 bolts right here, 4 screws. You loosen those screws, and then it'll allow you to adjust this up and down to get tension on the chain. Capacitor up here at the top, and that's for the motor. A lot of times when that capacitor fails, you'll find that the motor is struggling to come up. And that's all that is. If you have to change a complete elevator, very simple process. You got a couple of bolts right here. This whole thing will drop down out of there once you remove those bolts. You can take this right here, this plug, unplug it, and it releases all these wires going to the elevator. So, very simple. If you want to check power coming from the front and see whether or not you're getting power back, here's a great place to test it. You can clip this, and this side right here is coming straight from the controller, so you can check power right there. Again, the yellow wire is going to be the up, orange for the down, and the red with the white stripe, that's going to be your common. So you could always read, if you wanted to test for up, if you see the up command in the front, then you can go between yellow and red, check for 208, 240 volts. Or if you're going down, it would be the orange and the red. Same thing. Now let's familiarize ourselves with the wiring on the controller itself on the rear side. Kind of give you a better layout and a good test point place. You've got 4 screws, 4 Phillips heads, 1, 2, 3, 4. Once we take those loose, we'll be able to drop this panel down, and then I'll show you how to hook that up. Once we've removed all the screws, the panel itself will slide down and drop down. Notice that you can take this panel and set it up on those little brackets, and then it'll sit right there, and that'll hold it in place while you work. A quick overview of the control panel. It's your power switch, on-off switch, your heat cook filter selector. Of course, this is your CC10 controller. This raised part is your output board. These are your control relays, so all your outputs will come out of this board. Inputs, these right here, this green and white wire, they're coming from the 16-pin connector. Those 2 are going out to your drain switches. You would not have this on your conventional unit. This is actually a timer board for the ventless hood that we're not dealing with today. Your terminal blocks. This is your relay. When you energize this switch right here, your power switch, it'll pull in this relay. It's a power relay, sends power to the terminal blocks. This transformer is a 208 to 18 volt transformer. It's taken the 208, turned it down to 18 volts for your controller. This is your high limit board. It's totally separate from your controller. In case something goes wrong with the controller, you want it to be independent, so it'll still catch that high limit, 450 degrees. You've got 2 fuse holders right down here in the center, and that's pretty much it. Oh, your lights over here, you've got your green, yellow, and your red light for your status lights. And down here in the corner, and you can see it better when you open up the bottom door, you can see it up underneath the bottom, but you have your alarm. There's a small alarm that goes off for cook done, all that kind of thing, or any kind of alarm cycles. Here we are at the Giles Fryer, and you can see right now we've got this set for 78 degrees. We're at 78 degrees. So we're just sitting there idling along, everything is good, when all of a sudden the drain opens. So if the drain opens, it's going to throw an alarm. Now you can silence the alarm, and you'll notice that the basket is also lifted. Whenever the drain opens, the basket's going to go ahead and lift. It's going to come on up. It says right here the drain's open, and it tells you open right here. You can press whatever button you want. Nothing's going to happen until you clear that drain open message. So once we clear the drain open message, now it's going to go ahead and give us a check oil level, ensure VAT's full, and then press start. You can silence it. You're ready to go. Again, basket's only going up. The basket won't ever go down. It's going to go up. And then we're going to press the start. Alarm set point reached because we were set at 78. So we'll go ahead and shut that off. And we're back to normal. And here we are in the older N7 style. Much of the equipment that you'll see out in the field will have these older controllers yet. But again, we're going ahead, we're rocking along. We've got a 1 minute and catfish selected. Menu number 1 is running, and all of a sudden the drain opens. It's hold, drain valve, basket's raising, the alarm is going off. We can silence the alarm, but we can't do anything else. It won't let us do anything else until we get that drain closed. So we'll go ahead, we're going to reach down in there, we close that drain. Now that the drain's closed, now it says push alarm reset. So it's closed. Now it says it's already done. So let's press the reset. We went right back to normal running. And of course now we can do our basket key up and down. We can go ahead and go down. We can go back to cooking at this point. This green and white wire, they're coming from the 16 pin connector. Those two are going out to your drain switches. Now you'll notice right up here right up here where my finger's at, these wires right here, these are going to your drain switch. So there's actually 2 switches in there. And they're wired normally open. One of these blacks goes to a switch and a blue, and then a black and a blue. So if you think you have a drain switch error and you can't figure out which one it is, you could take these 2 right here loose and then ohm them out from here and check black to blue and see if you're getting a closed circuit. And you should be getting 2 closed circuits. They're actually wired in series so that if either one of them is open, it will give a drain open alarm to the controller and not let it heat. They did the additional one. Sometimes with a single one, it would over age. It would go ahead and close and stay closed. So even though you had your drain open, it would still show a closed one, and it would not interrupt the heat cycle. Okay, so let's say that you're getting a drain switch error, and you've determined that when you close the drain, both of the plungers are up, but you want to get the customer running while you're waiting to get the replacement drain switch. More than likely, it's just one of them that's gone. So if you follow this green and this white wire up, what you'll find is that they go right here and they terminate at these blue wires. So we're going to take the blue wires loose. These little Wago wire nuts, if you just pull down the little clip, the orange clip, it'll release the wire. Okay. Now, if you follow them again, they come out and they also go to black, I mentioned before. So we're going to release both of the black. So now we've got the 2 black wires and blue wires loose. So let's go ahead, we're going to clip onto one of these blue wires. We've got the drain closed right now. Let's see if we can find, you see that right there, that's a closed circuit. So that's a good switch. We could wire that switch up. If we wire this one up, it's not. But now, because these are both good, it will go to the other one. But now we know that because these are ringing out and it's closed, that is a closed circuit. So what we could do, if we had to, let's keep hold of these 2 right here. We need to make sure that we have these 2. But what we would do is take one of the black wires and hook it to the white, the one that rang out that we know is a good switch. Okay, and then we'll take this blue one and we'll put it with the green. So we're leaving the other switch completely out of the circuit. Okay, now we're ready to run on just one switch. Okay, so we're coming out on the green, hitting our blue wire, going to our switch, coming back on our black. We've got one switch right now working. We do need to come back and replace that other switch, but for the meantime, they can run safely with one switch, and we know what the issue is. Okay, so then come back later and change that switch. So these are your drain switches here, and you'd have to take these two nuts off to gain access. There's studs on the other side, so there's nothing to hold on to. Once I got that off, I can remove this cover, and you can see your two drain switches right here. Now when it comes to replacing them, they just run right up through this conduit. So you're going to go ahead and take these two loose right here, and you do have a Phillips head on the back side. You'll have to hold on to that Phillips head from the other side as you're taking these loose. And you'll see right here we've got this cam, and as this comes around, see, she'll make that cam, and it hits that cam, which pushes the switches in to engage those switches. And that's all there is to it. But when you get ready to do it, the easiest way to do this is to go ahead, if you know which one of these switches is bad, you can go ahead and clip your wires here, tie your new wires from your new switch onto them, and then just pull them right up through that conduit. It'll pick it right up back into the front. And then when you're done, make sure, of course, that they're operating correctly. Then you're going to slip this cover back on, and tighten everything back up, and you should be good to go. Again, very important that you keep these switches in place. If you do have to bypass one, please come back and get the other one. Should we lose connection with the main variable temperature thermocouple, and of course that's the little short one that's up underneath your high limit probe. If you lose connection with that somehow, if they break it, or the wire comes loose or it gets broken somehow, then you're going to get an ERO1, and again, it's going to flash up. It's going to kill your heat cycle, so you won't have any more heat, but you'll get an ERO1. And it will not be, there's no silence in it, no getting away from it, nothing will work for you. So at that point, you just need to go ahead, shut it down, try to find out where that probe is broke loose. Experience a problem with the variable probe, which is your main temperature probe. You could be going ahead and you're just heating and everything is just fine. Temperatures are slowly coming up. And then all of a sudden, you have a break in the line. Boom, it goes to oil probe error 13 and tells you that there's a problem with your main probe. Now even if it happens to fix itself, it will not come back on. You'll have to go ahead, shut the unit down, fix the problem, and then turn it back on. Your element probe is of course the one on the left that is tied directly to the element. What you'll see is you should see an error 2 message if it loses a connection. You'll notice now we got an error 2. We of course have no heat. Our element sensor, we would get an alarm, and that alarm would come out and actually tell us that's what that is, and that we would have to go ahead and cycle. Here we are, error alarm, element probe, cycle unit power, error 15. Now, if I go ahead and I cycle the power as is suggested, the unit will come back up. Of course, it's going to give me that alarm, power failure. If I press the preheat, it's going to go ahead and try to heat. Now, if I have not corrected the issue, it's going to come right back. So normally what that means is that I have a broken lead. I have a problem with getting any kind of an input. It's not seeing that element sensor. So we need to go ahead and try to figure out what that problem is. Related to that element sensor, if they try to fire the unit up without enough oil on the element, you will exceed our max element temperature setting, which is typically 580 to 600 degrees. If that happens, then you're going to go ahead and you're going to get a message, an ER11 message, which is going to go ahead and shut your heating down, and then it'll go into an alarm and shut the heating down. And again, stop, ER11, oil level, max element temp, everything shuts off. You can silence the alarm, but you cannot do anything else. Your basket will rise up, but if you exceed that maximum element temperature, this is not the oil, and you'll notice that it says check oil level, and that's because if the oil level gets below that element sensor, that element can easily exceed 580 to 600 degrees, and once it does that, it's just an extra safety to help prevent fires. And the only way to correct this is you have to actually get the oil back up. You'll have to turn the unit off. You'll have to correct the issue, and then when you turn it back on, it'll come right back up. Everything comes up like it's supposed to, and you're good to go again, but you'll have to restart all your menu. Now if we were to have the unit running and the oil got below the element, that element sensor would definitely cause it to go into alarm. And when it causes it to go into alarm, it will display on here, like there, error alarm, max element temperature. It's exceeded that max element temperature setting that we have, that we'd established back during our user settings. So we're going to get an ER19. Now, if for whatever reason it cools back down, it will go ahead and it will allow it to reset by pressing start. Sometimes during the morning times when you try to fire the unit up, if you have extremely cold oil, the oil will heat in a certain area and it will get above that temperature, and it'll give you error messages like that every once in a while. But by just stirring the oil, pressing the start button, it'll clear it and you'll be able to get beyond it. But that is a safety, just like having the drain valve switch to keep them from firing the unit up if the oil gets too low. Now on this particular unit with the CC10, we have 4 temperature probes. We have our element probe. This probe comes in, it is mounted directly to the heat element. So it's looking at the temperature of that heat element. So if they let the oil get down like it is now, this element will exceed 580 degrees and it will shut it down before that oil can flash. So it's an additional safety, in addition to the drain switch if the drain is open. Of course, this was your oil return. This right here is what we call the 4th probe. This is your oil level probe. So if the oil level drops below, and you'll see that it's right here at the add mark, we got max full add, but you'll see right here, that's where it's at. If it drops down below that, it will cause it to shut down. It will send a message to the controller and let you know. Right here, you can see just the start of it. This is your high limit probe. It comes over, it runs through this bracket, and then it is bent just to the outside of the elements. So if the oil gets over 450 degrees, it will shut it down. Okay, and just below the high limit probe is your actual variable probe, the one that is controlling the oil temperature. So if you're ever going to check calibration, that's where you want to check. You want to try to set your probe right there next to that little short stubby probe. It just barely sticks through there. Okay, and then of course we got your heat element brackets right here that hold everything in place. There's 4 of these around these elements. You've got 3 different elements in here. So the brackets, they look like a comb on the back side. They go in there, they hold the elements apart, and then these plates go on there. They need to be in place, Expansion and contraction as it heats and cools will sometimes loosen up these screws. So a good preventive maintenance thing is to come through and just make sure these are tight whenever you come in and the oil is down. Go ahead and snug them up. Again, element probe, you'll see it's right against the element, tightened up nice and tight against the element. Your oil level probe, your high limit probe, and below that your variable probe. We have 3 probes coming from the vat. There's 4 altogether, if you recall. We had one that was at oil level. That is this one right here. It goes to the second terminal block. Then you've got your variable probe, which is this one right here. It goes to the first terminal block, second set of screws. And then this one right here is your element probe. If you remember right, it's the one that's actually sitting right on the element and looking at the temperature of the heat element. The 4th one is your high limit probe, and it's right back here. It goes to this high limit module alone. Again, separate in case something goes crazy or wonky with the controller. It'll go ahead and catch it on its own and shut it down if it hits 450 degrees. It's an additional safety, one that's actually mandated by UL. So it is separated from the others. All the other 3 go to the controller. Right here, here's your high limit probe. There's your variable probe down below that. And then right up here at the top, right next to where you can still see the add mark, even on this side, you'll find that add level probe. So all of those, just undo the ferrule and you can pull the probe right out the back. When you order a new probe, always add a -R suffix, and that'll get you the little 45111 compression ferrule that you'll need to replace it. You'll reuse that nut, slide it back in, snug her back up, and you're good to go. Your element probe is tied in right, it goes in right here, insert in here, and then strap to the element. Now I just want you to know, regardless of which controller you have, the high limit function works the same. The high limit module, as mentioned before, is separate from the controller, so it will not send a message. You will not get a message here on your screen telling you that it's in high limit. Indeed, what will happen is you'll have the power, it's trying to heat, and then the high limit light will come on. When that comes on, you've dropped out the bottom contactor in the rear. The bottom contactor is your safety contactor, so now no power is running the 3 phases or 2-phase, single phase, depending on which you've got. But the power going through the contactors will no longer go through that first contactor, so it drops all power to the heat elements. Now, in order to reset the high limit, of course the temperature has to drop below the preset temp, and then just turning the power off, and then once it resets, you can turn the power back on, and when you turn the power back on, if it is below the high limit temperature setting, then it will stay off. In most cases, what you're going to find is that the probe is actually, if it's doing it, say at 200 and some degrees or something like that, as opposed to the 450 degrees that it's set for, what you're going to find is that the tip of that element or probe, the tip of the probe is too close to the heat element. So then you're going to want to go ahead and make the adjustment that I'm to show you in the next slide. Time to see about customizing our controllers. With the CC10, you can customize it, and these are going to be the user settings, and these are actually available in the manual. To access them, you press the time clock and then 9999 and start. And then the first thing, it's going to say user settings left or right. We're going to go to the right. This is your steps, number 1. We're going to leave it in Fahrenheit. That's a good place to leave it. Now, if we wanted to change this, at this point we would press the edit key, and then you'll notice we've got the 2 and 8, so we can go up or we can go down. We're going to leave it in Fahrenheit though, so we're going to press edit, and that saved it, and then we can go on to the next setting. Force filter is in the off position on this unit. I'm going to go ahead and turn that on. Personally, like the force filter, I'm going to do edit to save it. With the force filter on, after whatever, we're going to put a number in there in just a minute, of cycles. And after that many cycles or batches of product, it will make the operator have to go ahead and filter. Okay, force filter snooze, I leave that off. What that is after that predetermined number reaches and it tells them to force filter, they can actually press a button to get past that and go ahead and cook one more cycle. The advantage of that is if it comes up during a lunch cycle or something like that, they might have to get one more batch out before they have the time to filter. The filter count, and this is where it is, it's number 4. After every 4 batches or cycles, I'm going to make them go ahead and filter. Guard bands 900, it's a function we do not use, so we'll always just leave that at 900. The maximum set point is the maximum oil temperature will allow them to run. Auto cool. What auto cool does is after a predetermined time, be it 20, 30 minutes, something like that, if the computer has not seen any input or any controls, nothing going on, no batches run, it'll automatically go into the cool mode. We're going to go ahead and turn that on. Okay, edit to save, and then here, auto cool time is set for 30 minutes. So after 30 minutes, it'll go ahead and drop to that cool temp, and we'll see what that is in just a second here. Audible alarm, 10 seconds. Every time it goes off, it'll alarm for 10 seconds or until somebody silences it. And here's our cool temp, 275 degrees. So after that 30 minutes, if it goes into automatic cooling, it'll drop to 275 degrees. Well, if you're running a 350 degree cook temp, that's only 75 degrees that it has to pick back up before you'll be ready to cook. But think of the energy you've saved. It makes the oil last longer. It's got a lot of advantages. Boil temp 200 degrees, that's standard. Filter reset 290. When I go into that force filter, the computer is looking for 2 things. It's looking for the drain switch to open. We've been through this already. And it's also looking for this temperature, for the internal vat temperature to drop below 290 degrees in this case. That was the kicker. That's the one that lets us know that they've actually drained the oil out. If the internal vat temp drops below 290 degrees, we know there's no oil in there, okay? Because that's just ambient temperature of an empty vat at that point. Boil out time, 30 minutes. If you were to use the boil out feature, it would go ahead and run for 30 minutes and then alarm and close. Stir alarm. The stir alarm is an alarm that's set up so that a percentage of the cycle, it will prompt them to go ahead and just take a stir stick and stir the product so it won't all stick together. This one's set at 62% of the cycle time. Key beep enabled, you can set that up so that you can hear if these will beep every time you press one. Language is English. You've got Spanish and French, our choices as well. And then we're back to Fahrenheit. You want to get out of here, you'll just press the clear button and we're out. Now if we want to go a little bit deeper, we go into the factory settings. Factory settings are going to be time clock 2750, and that's Giles' street address. So if you ever get stuck, look at the manual. You'll see our street address on there, 2750, and then press start. Factory settings left or right. Interlock switch, that's where you get that power failure when you first turn the unit on. If you turn that off, you won't get that. It'll go directly into heating and all. We like the interlock start because if you have a power outage, it does take someone else to go ahead and push that start button before that unit will start heating up again. That's great if you have a place that comes up with low voltage. It'll save on your contactors, and it's a safety factor. Now we know that someone is aware that this fryer is turned back on. Ventless hood, if you have the recirculating ventless hood option, then you'd want to have that turned on. All that does, it enables the computer to look at all of the safeties in the hood to see if the filters are there, if the air switch is being made, that type of thing. The maximum element temperature, 560 degrees. What that is you've got an element sensor over on the left side of that fry vat, and that element sensor is looking at the temperature of the actual heat element, not the oil, but the heat element. And at 560 degrees, it's going to shut that heat element down because it knows there's no oil in there. If there's oil in there, it'll never get to that temperature. Hysteresis, 3 degrees. 3 degrees below set point, it'll call for heat. It'll heat it up to the set point and shut it back off. Hysteresis 2, on a gas, the gas GGF 720 is a large gas units. There is a secondary valve, and that one operates off that hysteresis 2. So if it continues past the 3, at 3 degrees, the primary valve will open and it'll fire up. If it continues to drop, at 6 degrees below, the second valve comes on so that it's got maximum heat, and it'll bring that heat up a little bit quicker. Both of those will drop out at set point. Oil temp offset is for calibration. Melt cycle off. The melt cycle you would use if you were using lard or sometimes some very heavy oils. We've had to turn it on to keep from getting alarms on that fourth probe, because it brings the temperature up a little bit slower and you've got oil movement. You won't get that fourth probe error coming out at first thing in the morning. That'll run until the temperature gets up to 270 degrees. After 270 degrees, it drops out of melt cycle and goes into normal heating mode. Element add level, add diff enable. That is, if you have the fourth probe, you would have this turned on. This particular unit, this controller is on an older unit that does not have that probe, but that's all. It just enables it, the controller, to look at that fourth probe. And then we go to the max element add diff. This is the differential that we're looking, the temperature differential between that fourth probe and that element probe. And if it does not, the temperature exceeds this, we know that there's not enough oil inside the vat, so we're going to go ahead, drop the heat elements out, and tell them to add oil. Passcode enable. You can enable this to keep anybody from making any changes to the controller, including menu changes. They can change menus, they just can't go into the individual menus and make any edits, or go into any of the settings that we've been looking at here. If you choose to do this, make sure that you contact Giles Tech Service at 1-800-554-4537, option 1, to get what the passcode is. You'd like to know that before you go ahead and enable it. And then we're back to our interlock switch. And clear, again, will get you out. One of the key features of the CC10 is its diagnostics feature. It'll help you to diagnose whether or not you might have an issue with a temperature probe. Again, we're going to hit the temperature button and then the number 77, 77, and start. And you see it comes up diagnostics, got a right and a left. We'll go to the right as always. And you can see the different temperature probes. Now, in an actual setting, those should all pretty much be the same. Again, this particular unit does not have an add level probe. If it did, with no oil in it, or with the temperature just sitting there, if everything has not been heated or anything, you can turn this on. And these should be relatively the same. You'll see the element right now is 73, the oil 73, the add is at 0, but it would be at 73 had it been in there. It even gives the board temperature. And then the differential between the element and the add level would be right here. Because we're not using it, we have it turned off. It's not even looking at that. It gives you the model for the single timer, which is what a GEF is. How many cycles, how much time has been spent in cool. And then we right back to here. On newer units, it actually has some diagnostics for your Wi-Fi. and you'll be able to check that out as well to make sure everything is going well with that. Okay, clear. Now if we hit time clock and then 8379 and start, we can test the keypads. Any keypad button that you press will display. So if we do 5, there's 5, press any key, and we'll do the temperature key, cool key, boil, alarm, 7, doesn't matter, and press clear to get out. That comes in really handy if you ever think you have a keypad issue and things aren't responding. Service mode technician programming in the for the N7, and this is actually technician only type programming, but to get into it is fairly simple. You're going to press the up arrow, then the down arrow, and then the basket key 2 times, and you see it comes up, it says type on off. That's the relay control, and you always want to leave that at on off. Okay, you'll notice that the clock button is lit up. That means it's the only active key, that in the up and downs. So we're going to press the clock to advance to the next setting. Maximum element temperature, 600 degrees. Typically with the GEF, we're going to set that at 580. So let's go bring this down to 580. Okay, once we press the clock, we're going to save that setting and advance to the next. We have the melt cycle turned off on this unit. If we were using a hard lard and we needed to slowly melt that product to get it to oil, then we could go ahead and we could turn that on. And of course you'd hit the clock to save it. But we're going to go ahead, and you can do the up or down, it'll cycle you through. We'll press the clock to save it and go to the next. Our cool temperature. The cool temperature, if I was to press this cool button and hold it during operation, if I'm not going to cook for a long time, why keep that oil at 350 degrees? I can save on my oil, save on my energy cost. So I'm just going to go ahead, I'm going to leave that at 200. They can either use it or not. A lot of times what they'll do is bump that up to 275 degrees, so it's a little closer to 350. Okay, the next is boil time, or boil temp. The boil temp should be at 200 degrees, always. We'll press the clock again. Stir percentage, there's an alarm that you can set up, and it'll go off, in this case, at 62% of the cycle. So whatever that time cycle is, at 62% of that, this is going to alarm and tell them to stir. And it's so that they can stir the product to keep it from sticking together. Advance to the next, audible for stir. So that's 5 seconds worth of alarm. When that stir alarm does come up, it's going to ring for 5 seconds and then it's going to go silent. Audible for done. It's a 10-second alarm. It's going to ring for 10 seconds. If they don't do anything, it'll shut off, or they can hit silence. If they happen to be there, they'll be able to hit the silent key and silence that alarm. Force filter. In this case, it's on. It says yes. What force filter does is it says that after a preset number of cook cycles, you have to filter the oil in order to keep cooking. It will not let you just say, I don't want to cook, or I don't want to filter, I want to keep on cooking. You cannot do that if its force filter is yes, and we're going to leave this in the yes. In most cases, you'll find it in no. Okay, and then filter count. So what we're saying is after every 4 cycles, we're going to make them go ahead and filter. If you had the force filter and no, this number would just set a reminder for every 4 cycles. It would come up and it would say filter to remind them to filter. All they'd have to do is hit the alarm silence, just keep on going, just ignore it, and just keep on cooking if they want to. Okay, boil time, that's 30 minutes. So if you go ahead and you use the boil key here, it'll go ahead and drop that temperature to the 200 degrees that we saw just a little while ago, and it'll go ahead and run for 30 minutes, and then it'll alarm before shutting the heat off. And then we're right back to hold. So we've gone through all of the steps And here we are back to hold. Now if we want to go into our factory settings, our factory settings are going to be the ones that they come from the factory preset. There are some that you may want to go in and change on occasion, but for the most part you're not going to really want to go into this. But to get into it, it's going to be the up arrow, the down arrow, and the cool button twice. Okay, and here we're going to read everything, the temperature units Fahrenheit. If we can go ahead and change that to Celsius if that's what we wanted, but we'll stay in Fahrenheit. Hit the clock to get advanced to the next. Guard band will always be at 400. It's a function that we don't use, so we just leave it set up there at 400 and it stays out of our way. Input J-type thermocouples. That's what it's looking for. Range low, they can never set a temperature less than that range low, which is 75 degrees. Range high, 375. Normally we'll go ahead and bump that down to 350. The hysteresis. What the hysteresis is when the if say our set point is 350 degrees, when it gets 3 degrees below that, 347, when it starts to bump over to 346, that 3 degrees is when it's going to kick the heat back on. It's going to heat to that 350, it's going to shut the heat off, and then when it cools back down to 347 to 346, it'll kick it back on and bring it back up. So that's what that hysteresis is. You got a hysteresis 2, and what that's for is only for the gas machines. The big GGF 720s, they have a dual gas valve. The 3F would be for the first gas valve, and then if the temperature continued to fall, then the other gas valve comes on to bring that temperature back up, and that's where the 6F comes in. Offset is OF. This is your calibration factor. It should typically be OF, 0, no calibration factor at all. If you have some kind of problem that you have to put one in, never want to adjust it more than 10 to 12 degrees, because the more you adjust it, as the temperature widens, so does this gap, and it'll get farther off. Typically not even something that you have to worry about, but if you get a store that is really particular and wants it down to that exact science, then you could have that problem. Now you see what happens if we don't do anything. If we don't touch any keys for 20 seconds, it'll go ahead and fault out. Now we have limited diagnostic capability with the older N7, but one thing that is very valuable and comes into play quite often is the keypad test, and I'm sure you'll want to use this one. And what you'll do is, with the unit in the off position as shown, you're going to press and hold the up and down arrows at the same time while turning on the power. Now hold those two buttons in until it completely boots up, and you'll see it says OTST. If it would have went to hold or ready or any other display, you would have had a problem with the keypad because it wasn't seeing the keypad presses of the up and down arrows. When it's in this one, you can go ahead and it says you can press any key. So if we press the clock, you'll see that it says clock key and the LED is lit. The alarm reset, same thing. 3, 5, 7, doesn't matter. Any of the keys, and it'll go ahead and tell you which one they were, so that you'll know that the computer is actually seeing the key that gets pressed. All right? Very, very important one to remember, especially as units get a little age on them. 3, 4 years out. Sometimes they last much longer than that, but anytime after 3 to 4 years, you might see that. And we do still have the keypads available, so you can purchase those for replacement. And to get out of this, all you do is turn the power off, and then when you return the power, cycle the power back on, it'll come back up in normal display.